All right, so today we're going to be talking about how to divide radicals. So we're going to simplify radicals using the quotient property of square roots. That's how we're going to divide the radicals. And the steps that we're going to do is first we're going to birthday cake the denominator. After that, we'll add any square roots to make it whole because we want them all to be paired up. There's be nothing left to go inside the house, nothing left inside the radical. Then we're going to add whatever we did to make it whole. We're going to add that also to the numerator because we got to keep it balanced. And then we'll simplify the numerator and then reduce any fractions that we can. So first, it's always the denominator, add to make it whole, do the same to the numerator, whatever we have to add to keep it balanced. Then we can simplify the numerator, and then we can reduce the fraction if we have the ability to. So, simplest form, notice we can have no radicands other than perfect squares. Excuse me, sorry. So in other words, those radicals have to be in simplest form. There can be no radicals in fractions, containing fractions, and we can have no radicals in the denominator. So a lot of places, a lot of things that we can't have. All right, so what does this quotient property of the square roots means? It means if we have a fraction inside, we can separate it as to two square roots on the outside. All right, so here we have the square root of 12 over 5. So we have to look at the denominator here, the 5. The 5, obviously, when we birthday cake it, is just 5. And because it's just 5, we have to add another 5 to pair it up. If I put another 5 to pair it up, this is going to be just fine. It's going to be paired up. There's going to be two 5s. But the 5 has to also go on the numerator so that we can go ahead and keep it balanced. Now we're going to have to do 9 times the 12, which will give us the square root of 60. On the denominator, we're going to have the square root of 25, which of course is 5. So now we're going to go ahead and simplify the square root of 60. Square root of 60 has 2, 2, 3, and 5, or 2 root 15. Last thing we want to do is simplify anything that we can here. And there's nothing we can, so that's it. So again, going through this again, we have the denominator, the 5, and we want to make that whole. So we have to add another 5 to it so that there's a pair. There's a pair of 5s, and that comes out as the square root of 25, which is just 5. I can't just add a 5 here because I feel like it. I got to balance it out with another 5. That gives me 60. Then I reduce the 60. That's 2 root 15. And then once I have reduced both of the radicals, I can go ahead and see if there's anything I can divide here. 2 and 5, there's nothing in common. I can't divide that, so that's my answer. So I always start with the denominator, and then I can move back to the numerator. All right, here we have the square root of 8. The square root of 8, we need to pair up. So you can pair it up with an 8, or if we birthday caked it, we could have done a 2. They chose to do the 8. It's a little bit longer to do it that way, but they chose to do it. And that gave me the 24n over 8. The 24 can be reduced. It's 2, 2, 2, and a 3. So that's 2. And notice the 2 and the 8 here, they can be reduced. The 6 is inside, leave it alone. So the 2 and 8 gets reduced down to just 4. And that's my answer. All right, here's 5 square roots of 2. I got to pair up the 2. I'm looking at the denominator first. That's where I start. So 2 with 2 gives me 4. I pair up with the 2 on top, and that gives me 10. So I have the square root of 10 over 2. And that's all I can do. Here's 27. So with 27, I'm birthday caking it. I get a bunch of 3s. So I need to add one more 3 to make this balance. I would have a 3 here and a set of 3s there. So I'm going to add one more 3. That gives me the 6 here. 27 times 3 is 81. 81 is a perfect square. That's just 9. So I have the square root of 6 over 9. When I have something like this, I got to put them together. So I get 5t over 10t. Well, 10 is just a 2 and a 5, so I have to work on simplifying that. Again, I'm looking at the denominator first. I ignore the numerator. Denominator first, pair it up, get the 100t squared, which then gives me just 10t. That numerator gets to be multiplied again. So 5 times 10 is 50, and t times t is t squared. So the numerator just gets whatever I have to do for the denominator. Once I've done that, I can go ahead and reduce it as best I can. So then I get 5t root 2. Now 5t and 10t, those can be reduced. The t's can cancel, and the 5 over 2 reduces to 1 over 2. So we have the square root of 2 over 2. All right. When there is a binomial in the denominator, we have to use what's called the conjugate. Well, what's the conjugate? It's the same as the denominator, except we're going to change the plus and the minus. The plus to a minus or the minus to a plus. What do I mean? If I have 1 plus 2 square roots of 3, the conjugate would be 1 minus 2 square roots of 3. So we always do the opposite sign. Remember, this is what a binomial looks like. It will have to have that plus in the middle or a minus, one of these two. And the conjugate is the other one, and that's what we multiply by. So let's look. So here we have a 3 over 5 minus the square root of 2. I can't just multiply by the square root of 2. It's just going to go ahead and move things around. So I have to multiply by what's called the conjugate. 5 minus the square root of 2 becomes 5 plus the square root of 2. And then I go ahead and multiply that out. This is going to be a distribute on the top, and on the bottom is going to be a Punnett square. Now, the great thing about that Punnett square is it's a difference of squares, one time plus, one time minus, and the middle terms will cancel out. So in the numerator, we're going to get 15 plus 3 square roots of 2. Then we get 25 minus 2, or the square root of 4, so which is 2. And I get 15 plus 3 square roots of 2 over 23. All right, do another one. So here I have 4 and 3 minus the square root of 5, so I have to multiply by 3 plus the square root of 5. That's the conjugate. So looking at the numerator over here, I'm going to do 4 times each of those, which gives me 12 plus 4 root 5. For the denominator, I got to Punnett square it. 3 times 3 is 9, negative 3 root 5 here, 3 root 5, and again, those are going to cancel, and square root of negative 25. Square root of negative 25 comes out here, the middle terms that are going to cancel. 9 square root of 25 is just 5, so 9 minus 5 is that 4 value. So by doing the conjugate, look at how nice that denominator ends up being. And so our numerator gets placed up here, denominator on the bottom, and now we can go ahead and divide. Now, the way that we divide one of these is all 3 of these things have to be divisible by the same number. Ignore the square roots, but these other numbers here have to be divisible, and they're all divisible by 4. Mistake here, this should have been 3 plus the square root of 5 over 1. So you really didn't even have to put the over 1, it could have just been 3 plus the square root of 5. And that's what I have for you today.